Okay, welcome to Architecting Healthcare Apps for Scale. My name is Nick. I am a staff engineer at a company called Redox, and all we do is healthcare integrations. Um, so, yeah, the goal of this talk is to kind of talk through a lot of the patterns that we see in the healthcare industry for integrating data. Um, Really going to focus on sort of like what the current state is, talk about the trade offs, and sometimes there's some confusion there. So we're gonna dive deep into it. Um, a lot of the patterns come from historic, just kind of like the way things have always been in healthcare. In some sense, like healthcare is cursed by being too early to APIs. So we have a lot of cruft and we have a lot of sort of old standards that aren't necessarily developer friendly. But recognizing that they're there and finding out how to leverage them can make you really powerful. Um, Finally, like recognizing these patterns early and sort of designing your app around them can ultimately help you scale a bunch. So, yeah, just to kind of set up the landscape here, I'm going to use these little diagrams for most of the talk. Um, the source system in this case might be an EHR. I mean, typically they generate a lot of data. Uh, the way to think about this is just like the source of truth. That's kind of where my source word is coming from here. Um, it could be really be in a system, but the sort of system of record for whatever kind of workflow you're trying to accomplish. Um, then there's sort of just like the receiver. So like it could be a client, it could be some downstream consumer of data. Ancillary system is a term that we use in healthcare. And it just kind of needs to have some kind of synchronization with that source system, get some data from it. It could be a lot of data. It could just be like one particular field that they care about. Not making a whole lot of specific claims here, just a generalization. And yeah, this is sort of the null case here. No connections. They don't integrate at all, and that's just a very bleak and unhappy world. The first pattern, though, is querying. So, interestingly, like query took a very long time to come along in healthcare. Um, the way this pattern works is that sort of app, is more of a client here, and it connects to the source system either through, any number of methods. But it sort of initiates a request, has some parameters that it says like, "Hey, do you have this?" And the source system responds back, synchronously or asynchronously with the data. Um, we're going to kind of dig into more of the trade-offs and the stuff later. Just kind of introducing the patterns now. Uh, you can extend query to sort of a real-time mode by adding events. So events are very, very common in healthcare. This is kind of one of the legacy things I mentioned, where HL7 version 2 is just sort of event-based, and you receive potentially millions of messages a day. In this case, the source system would send out a notification. It might have all the information you need. It might have very little information, and then you go back and query for more information. This is a really nice pattern because you expose sort of less of the information on the outbound side, and you're able to go back and pull potentially more information through the query. Event carried state transfer is a kind of a big long word for saying that you don't have that query part. Um, in this world, you put everything that you need into the payload itself. So you get kind of fatter payloads, and then you sort of have to worry about state. Um, you can imagine if I'm receiving a bunch of updates and I miss one, I could miss sort of an important piece of information, and I wouldn't have that luxury of going back and querying and potentially seeing like what the current state of the system is. Um, this is another one that's sort of interesting in HL7 version 2 because this is sort of the only thing you have access to. There's another pattern called event sourcing, which I think would be really awesome for healthcare, but no one really does. It's kind of hard to do. In this world, you have events, but they sort of build on top of each other. It's sort of the way Git works. It's sort of the way Bitcoin works. So you sort of have this kind of database that would support that. in yeah, in practical terms, I think it's a little bit inefficient. The scope um, and sort of complexity of healthcare data doesn't lend itself to this type of flow. But I'm including it here because it's something that's cool and at least worth discussing. Um, Finally, there's sort of the update command type of interaction. So in this case, um, the source system or the app, either direction, will say, "Hey, do this thing, take this action." It's not necessarily a event. It's more of a sort of command, right? So you're saying, you know, something needs to change in the state of your system, whereas an event is more like less opinionated. Um, Another pattern I just like include here, I'm not going to talk about anymore, is single sign-on. This is an interesting part of healthcare integrations typically. So, um, a very common workflow is to embed an application within an EHR. And there's a whole sort of flow here, and there's a specific standard in healthcare called Smart on Fhir that gives you additional access to data, so you can go back and do a query workflow. But here, basically, it's a source system uh, launches an app. Um, IDP is an identity provider. Service provider is the app. And then that user is somehow potentially involved in the authorization decision and things like that. So yeah, if it comes to needing to launch your app within the context of an EHR, this is a pattern you have to worry about. But it's fairly standard. There's SAML. Smart on Fhir is just kind of based on OAuth, so it's not too hard to figure out. And a lot of the sort of vendors out there, including Redox, have tailored solutions to that. Cool. So let's go back to query. Again, this is that source system coming into, or sorry, that client coming into the source system and making a request for data, and ideally getting it back. So one of the nice things about querying is just the sort of statelessness of it. You can go query, you get the most current snapshot of whatever data you're trying to get to. And if you come back and query 5 minutes later, like it might not change, it might change. You have very high confidence that you can just use that data, right? You don't have to sort of worry about, is it out of date? Do I have to keep track of something between requests? With that, the big place we see query in healthcare is the new Fhir standard. I guess I shouldn't say new; it's like 10 years old at this point. But there was not really query before Fhir, and Fhir is a sort of really RESTful, based in REST principles architecture. And the kind of idea there again is you can sort of cache queries. You can sort of not have to worry about like chaining things into one another. And if there's sort of like, let's say you have pagination, Fhir tells you how to do pagination where you have links within the response. There are some downsides to this. So obviously, like querying, you don't get real-time updates. You have to sort of poll. That can be a problem if, like, let's say you have some kind of critical application that needs to know within a few seconds the status of a patient or something like that. You're either polling every few seconds or you need a different kind of pattern. The other thing I'll call out here is just sort of there's a lack of resilience. So you're depending a lot on the source system to serve up to handle the request and sort of respond back to you. It again, if you get rate limited or something from kind of doing that aggressive polling, you're just kind of out of luck. So you have to like take a little bit of that into consideration when designing your app. The event plus query kind of solves a bunch of those problems. So you get to still have that kind of low coupling that you get from querying, but you don't necessarily have to poll anymore. You can kind of just listen for events, respond to only the ones you care about. and it's, you know, a little bit more flexible of an architecture. Um, the real con to this is obviously, aside from having sort of like two connections, two directions of flow, sometimes that means you're talking to like two different teams that need to set that up for you. Um, it does get a little bit complicated for the source system, right? If you have multiple notifications going out um, to all these different systems and they all have to come back and actually query for data, you still kind of are generating a lot of queries against your system, and that could be a problem. One possible solution for that is event carried state transfer, and this is where we see HL7 version 2 really kind of being the standard bearer for this, and that's really just like a product of it being invented in the 90s and sort of that being the best way to do it. The way this works is the source system kind of blasts out a big payload of data according to some kind of format, according to some kind of standard. And then it's on the receiver to just receive it and just say like, hey, I got it or I didn't get it, and kind of do whatever they want with it. So the benefits of this is it's like very decoupled, right? You just kind of listen to a feed and you can do whatever you want with it. The source system doesn't need to do too much logic or anything like that. Like they just kind of need to format that payload and blast it out. The cons, just like the volume of it, right? So whatever kind of triggers you have for that particular integration, I mentioned some things can go up into the millions, right? Typically, we see that with like what we call an ADT feed. So as a patient moves through the hospital, you could get like a message like every time somebody clicks, onto their chart or something like that. I used to work at Epic, and it's like possible to sort of configure things to be very aggressive in sending messages. So there's sort of a network intensity and a data intensity there that you have to deal with and plan for. Obviously, like handling events, you would want to invest in kind of like a event bus type of system, a Kafka or something like that. And then you also sort of have this problem of consistency over time, right? So you are getting a snapshot of data as it comes through, but you aren't necessarily sure at any given time that you have the most up-to-date picture. Which, depending on like sort of your data needs, that might be a deal breaker. That might be fine. And you sort of have to kind of reconcile all the messages for a patient in order as they come in. So eventually, once you get through everything, you have a complete picture, but it's sort of hard to know at any given time point whether or not you do have a complete picture. Cool. So yeah, update command is this kind of just lives on its own. In some sense, there's no way to get rid of it. A lot of HL7 version 2 messages also look like this. For example, like creating an order really just kind of looks like, hey, here's an order, create it. The real con here is this sort of high level of coupling. It's also a pro, right? Like you want to be able to create orders in other systems and sort of maybe like modify data and create new entities within an EHR if you're doing integrations. It's just necessary kind of evil. In most cases, it involves a lot of testing, right? You want to make sure that your system is not creating bad data, not creating duplicate patients, not sort of affecting other downstream systems in bad ways. So it takes a long time, and it's kind of hard to do. So yeah, just to kind of quickly wrap up with the standards, I've tried to touch on these throughout the talk. Like I mentioned, HL7 version 2 has been around for 30 plus years. It most closely resembles that event carried state transfer. So you get a big bundle, big payload of data. You don't have to do anything with it, or you can do everything with it. The sort of source system is agnostic to what you do with it. Of course, you have to convince the people that like run the source system to send it to you. But beyond that, then it's sort of like up to you what you want to do with it. Again, some domains within HL7 version 2 look more like commands that they mutate data. They sort of are intended to like create new records in a system, and they're not sort of useful as updates. There's some context there that helps too, where it's like, sometimes it's just useful as like a hey notification, but for some systems, it's intended to like actually mutate state. um, Fhir, I mentioned, is really like interesting. It's very architecture agnostic. So Fhir is a data model. Fhir also has like a RESTful API that they specify. The way we've seen Fhir evolve so far is just that query workflow. So I mentioned the query architecture pattern was like largely missing for a good part of the last 30 years. Fhir only recently came along in the last 10 years or so. And now query APIs are sort of federally mandated for patients to be able to use. So it's nice, especially for that workflow where it's like, hey, I want to use Apple Health on my phone to see my health records. I don't need to listen for live updates. It actually does polling. Like it's fine to just pull for new results like once a day. And yeah, it's been very successful in that domain. Other areas of Fhir, I think, are still coming along. At Redox, we're focused a lot on kind of doing that event carried state transfer, and also these sort of event plus query workflows. In that world, you are getting like a lot more data, up to like 10 kilobytes of data in one payload. Fhir is pretty verbose, but depending on kind of those trade-offs I talked about earlier, it might be worth it. CDA is another standard from HL7. So if you've heard of TEFCA or you've heard of Care Quality, Commonweal, those types of networks, they're all based on CDA. CDA was kind of a middle child between HL7 version 2 and Fhir. And it's these very large XML documents. The acronym stands for Clinical Document Architecture. They have a lot of useful information. Again, it's very architecture agnostic. That standard only specifies sort of the data format and the data model. What has evolved around it, though, is more of a query pattern. There's also sort of a push, which, depending on how you look at it, is kind of like a command, or like the event carried state transfer, where you're sending out a snapshot. The majority of the workflow, though, is that query. And so you sort of, you go up to a network like Care Quality and you say like, hey, do you have this patient as a query? And then, hey, what documents do you have for them? And you say, okay, give me that document, give me that document. And that's really just kind of only come on in the last 5 to 10 years as a sort of scaling type of thing. One of the interesting products we offer at Redox is sort of a way to handle that inbound query volume, right? Because when you connect to a network like that, you're connecting to literally everybody who's on the network, and they have the opportunity to query you. And so if you want to join one of these networks, you have to be a responder in addition to a querier. So it's like a give and take kind of thing. And if you're not ready to handle that query volume, you could be sort of getting in trouble and getting a slap on the wrist. So yeah, that's an interesting like technical challenge, and our products kind of helps you with that scale. Yeah. For further reading, there's a great article and talk by Martin Fowler, where he breaks down some of these event-driven architecture things. I really recommend it. And yeah, thanks for watching. Excited to have met you all in New York. And feel free to reach out to me with any questions by email or Twitter. And have a great day.